We would like to welcome Associate Professor Dr. Mohd Arif Agam from UTHM. Okay, let me introduce. Associate Professor Mohd Arif Agam completed his PhD from Nanoscale Physics Research Laboratory, University of Birmingham, UK in 2006. Awarded as Best Malaysian UK Student in 2005 by the Malaysian government and published more than 60 research papers in reputed journals. His research interests span from polymeresis to functional nanomaterials, especially for the environment preservation. And it's focused more on overexposure of doped polymers in direct fabrication of gravitic materials such as diamond-like carbon for advanced materials research and applications. He was a visiting scholar to Tianjin University, China, in 2019 and visiting professor to Ibn Tufayl in Kenitra, Morocco, 2020. Okay, please welcome our invited speaker with his presentation entitled Assessment of Anticholinesterase Effect of Polyvinylpyrrolidone / silver nanocomposite biosynthesis by Pandanus atrocarpus extract. Please welcome.
For helping me. So my name is Dr. Arif. I'm from UTHM. I would like to introduce you to my student work, recently graduated PhD student. The title is Bio-Inspired Synthesis, Characterizations, and Biological Activities of PVP, Polyvinylpyrrolidone, with argentum nanoparticles. We call it nanocomposite using Pandanus atrocarpus extract. Okay, so I would like to talk about, first thing is about my PhD. I realized that in research, we are actually doing some manipulations. So research is about manipulation. So what is the thing that you manipulate? So for my research during my PhD, I try to manipulate the polystyrene beads that is in 500 nanometer. So how do I manipulate it? I bombard it with electron beam. So when I bombard it with electron beam, I found that the shrinkage of these polystyrene beads in 500 nanometer reduce slowly during the electron beam, meaning that the energy that they receive from the electrons, they started to restructure themselves. They become smaller. So that's become my entire quest since 2002 until now. I'm trying to look into this polymer restructuring because they are being modified by energy they receive from the electron. So when I'm back, so this is again, you can see that by bombarding one bit of polystyrene, we can see the changes, and we can do some measurements. Of course, we now, when you try to manipulate, you try to look into what is the parameter involved, the electron, the accelerations of the electrons, the current accumulations, the spot size of your beam. All this will be important for your research. So meaning that if you look it back from this diagram, you start with the ideas of bombarding the nanospheres. Now you can see that it involves a lot of things. Now, meaning that you start from one point, you get a lot of other points. So you got your spot size of your beam, you got how much of electron accumulations to your polystyrene, and then you will try to measure the polystyrenes, and you find that after I finished my PhD, I'm interested in finding what happened to the polymer, but at that time it's quite difficult to investigate it. So it became my quest to understand what happened to this polystyrene. Of course, the work is related to lithography. Okay, So lithography is very important for semiconductor when you can create patterns, and from that pattern you get your IC, integrated circuits. So meaning that this polystyrene can be used as polymerizes. So you can see that polystyrene is about negative resist. Then I could look at, is it possible to make them change to become positive resist? So we did that, but I'm not reporting it. Now, if you look at your research, a fruitful PhD venture is just like this image. Okay, you start at one point, you get many. Okay, you got a lot of parameter to measure. You choose the parameter to strengthen your research, and then later on, when you get so many, you started to eliminating some of undesired materials. Then you start to focus on something so that you got at the end you got a team of your research. So in my team of my research during my PhD is modifying the polymer structure by electron beam. So that's I get my PhD. So it's so simple to get a PhD if you realize how the mapping of your research. So this is again, this is actually what I said as chaos theory. So you start with one point, you end up at many, and then later on you focus it again back to one point. That's how your PhD will be successful. So I'm keep telling my student to do things like this. Try to map your things, try to make your PhD, and of course you can see that all the line
Sorry,
is
Prof, to interrupt.
what?
There are, there are 5 minutes more to
Okay.
present.
Wow.
Okay, thank you.
So fast. Okay. So now if you see this, okay, this is my research is, you see that I started with electron beams and I'm ahead at that time from Rice universities and Nottingham University. So sometimes your work will be like that. Okay, so this is some of my uh, deviation from my PhD. From electron beam, I started to use laser and dope to the polymer and do the catalysis of the polymer with dope materials. And look later on from Nabila, we can get the energy band gap. Now we go to solar cells. Now for Abdullah, we go to medical purposes that come the anti uh, enzymatic nature of the research. So this is how we change the polymer to become graphene and diamond-like carbon. We did get graphene, and this is the energy band gap. And of course, later on for medical purposes, we try to put nanocomposite, create the nanocomposite between polymer and nanoparticles. And of course, we try to go into medical research. For this case, we look into Alzheimer's disease. And of course, we look at the synthesis, UVVs, PSAM, FEM, XRD, and we got that nanoparticles. Now, once we get the nanoparticle, we try to check it whether it is stabilized or not. Then we look at the size, and then we can look at the XRD to confirm that we managed to synthesize the PVP Argentine nanocomposite. And of course, you try to look with other scanning to make sure that you get your particles, and then you do the enzymatic activity investigations. Then you found that with the PVP and Argentine nanoparticles, we can reduce the enzyme that being uh, uh, very what I call it, attacking your brain, and that enzyme that being produced when you are getting old, that making you become senile or forgetting about all of the things. I think that's wrap up of my presentation. Thank you. Hello.
Okay, thank you, Prof.
Okay.
So we move on to the Q&A session. Okay, let's see what question we get. Okay, doctor, there is question from Facebook user.
Okay.
Doctor, how compatible is the biocompatibility of the materials to cells in vitro and in vivo?
Okay, that's beyond my things actually, because I'm concentrating on the nanoparticles. That there is another guy in Iraq, a doctor, that looking into it. But for the time being, I think our research is not in vivo. It will be outside. So meaning that we create the enzyme outside and investigate it, not in the body. So because I think we need to have patience, we need to have regulation whatsoever. So it's not possible for this time. But we are looking into perhaps in the future for viruses like COVID-19 or so, but we are still at a very early stage. Okay, I hope I
Okay.
answered that questions.
Okay, thank you, Prof, for the question.
Mm.
Okay,